Similarly, in this case, there would be no charge stored inside, only the charge would be stored only outside. And if I apply some electric field like this, what would happen? Some positive charge will start settling in this side, and some negative charge would start settling in this side, and the distribution should be like in such a way that it produces some electric field in this direction, which cancel out the electric field it produces in this direction. So both fields get cancelled out, and the net resultant of electric field is this zero in this region. And similarly it would happen here. But now if I also, let's say there is some charge produced in the surface, but initially it was neutral, so there would be net no charge on the surface. So if I take the sigma dA summation on the surface, it would become 0 because the total charge on the surface would be 0. Now if I put some charge inside this cavity, let's say some q charge, then what would happen? This charge would produce some electric field in this region, and to cancel out this electric field we need a counter charge just at this inner surface, because if this charge layer is found at some further distance, there would be some electric field due to this charge here also. As according to the Gauss law, there would be flux in this region due to this charge, and if there is flux, there would be some electric field also. So it is important that we have to put all the opposite sign charges, means minus q charges, in this inner surface, so that the Gaussian surface I draw here should have net zero charge inside, and the net flux would be 0. So it gives a chances, it means if flux is 0, then it is possible that E can be 0 or E can not be 0 at all positions. Means it is possible that E is 0 at all positions, or it is also possible that E is in this direction at some position and it is in opposite direction at some positions. And means in case of E dot dA, it is possible that E is 0 everywhere, that's why the flux is 0, or in some cases this value is negative, and in some cases this value is positive, that's why the sum is 0. So flux must be 0 to get this case, to achieve this case. So to get the flux 0, we will put negative charge in this inner surface, and if there is some negative charge in this surface, since no charge can lie in this surface, we must put some positive charge equal to this in this outer surface. So that's the thing, that we have to put some plus q charge in the outer surface. But now if I say that, let's start from the beginning. Let's say I have put some plus q charge on this body, some q charge on this body. If I put some q charge on this body, let's say this is cavity, then all the charge will start residing on this surface, so that all charge would be, let's say q charge with any sign, doesn't matter, all this charge will reside on the outer surface. Now if I put some plus q charge here, then minus q charge will lie in this inner surface, and then minus q charge should also go outside due to the conservation of charge. So q charge will be produced at the outer surface also. So total charge at the outer surface would be q plus q, capital Q plus small q, and inside this is q charge and this is minus q charge here. The flux in this region would be 0 everywhere in each Gaussian surface we draw, due to both plus and minus equal charges, while these two charges will not cause any flux inside because this is the outer surface. That's it.